Hey everybody, I hope that you're doing well. So today's lesson is section 3.3, and what we're looking at is this special form of the line, equation of a line called a slope-intercept form. Now, if you couldn't guess, the two main pieces that we're going to know from putting this, or getting this form, is the slope and the y-intercept, slope-intercept. So let me go ahead and kind of give you an example and we'll talk about it. If you get y by itself, solve for y, we noticed last time that the slope was the number sitting right next to the x. The one beside the x is the slope. Well, that's not the only special number you know when you get y equals. You also know the y-intercept. Slope, y-intercept. So we have these two special numbers. Now, we can use these. What we're going to start with today is we're going to start using these to graph, okay? Because this is a lot faster than making a table. Faster, and some people think way easier, faster than a table. Okay, now we need to start bringing back some of those words we talked about last time when talking about what slope was, okay? So let's remember that slope was a rate of change, how things were changing, and that was rise over run. This is the change in the y direction and the change in the x direction. So y's, x's. Okay. So when I graph on a graph paper, and I'm at a certain point, from here, if I know the slope, I can find the next point because I will know how much it is rising and how much it is running. Okay? How much is going up and over or down and over, and I can put another dot. Okay? Now, this all leads to what in the world is the y-intercept? Okay? And some people like to think of this as our starting point. Okay, which will also make sense when we get to word problems. So this is the beginning. This is where we're going to start graphing from, because if I know how something's changing, say I know you're growing 2 inches per year. Well, how tall were you 3 years ago? Well, I can't tell you that unless I know how tall you are now, or how tall, I need a starting point. So the y-intercept is the starting point. So what the y-intercept is if you're looking at a grid, that will be the point where the graph crosses the y-axis. So that would be the point where the graph crosses the y-axis. Okay, so we're always going to find a starting point, a point to start, by just looking at the y-intercept. So we're starting at the point where that crosses at 5, and then we can move based off of our slope, which is rise over run. Okay? Now, that sounds like a little bit of a lot, but once you see some examples, it's not that bad. Okay? So let's actually jump in. Now, I will tell you the letters they use in the textbook for these things are an M for slope, which we already mentioned, and they use a lowercase b for y-intercept. Okay? So let's actually get started with some examples of using this to graph. So let's graph this. Let's start with 1y equals negative 3 over 2x plus 4. Okay? And so right off the bat, I know my starting point. Okay? Starting point. I know that I have the y-intercept that is at 4. So that means on the y-axis, if I go to 4, 1, 2, 3, 4, and put a point, that's where we're going to start graphing this graph from. Okay, now let's look at the slope. There's the slope. So slope equals negative 3 over 2. So remember, we're going to say this is the rise over the run. Okay, so I start off with one with a negative right off the bat. I always, and I would suggest you do this too, go ahead and attach the negative to the top, because it's a lot easier to think about rising up and down as a positive or a negative. So if it were positive, I'm going to rise up. If it's a negative slope, I'm going to fall or rise down. Okay, so -3, and then I'm going to always try to run. I'm going to always run to the right just to make this simple. Okay, so I have a rise and a run. So from my starting point, I'm going to count a rise and a run and put another point. So let's see, a rise of -3, that'd be down 3 over 2. So down 1, 2, 3, run 2, 1, 2. And right here I'm going to put another point. Whoops, got bad aim there. So if you were counting, I went down 1, 2, 3, and over 2, 1, 2. Obviously don't put these little squiggles on your graph, but so does everybody understand why I went down? That's because it's a negative fraction, so I'm going to go down, and I'm always going to just run to the right. Now, we require you to have 3 points on your graph, so we're actually going to do this again, but if I do this again from here, down 3 and over 2, I'm just going to end up at the same point. So what I do now is I start from my second point, and I do that same rise over run, down 3, 1, 2, 3, over 2, 1, 2. And as long as you count correctly, all your points should line up in a beautiful straight line. Now isn't that awesome, because that did not take much effort at all to graph. Alright. So let's do another example. Let's see more things that we can see, okay? So I'm not going to do a whole lot of examples of these, but let's look at one like this. -x plus 2y equals -8. Okay. This one is not in slope-intercept form. This one is not in that special form that I have. This one does not have y equals. That's what I need. Now, if you've noticed, solving for y equals or getting y by itself is a skill that we seem to use a lot, and it is very important. So if you struggle with it, practice it some more. So let's get y by itself. So I'm going to get rid of this -x. So I'm going to add x to both sides. So that's 2y will equal, now be very careful here. This is an x and this is an 8. So they are not like, okay, not like at all. So I cannot combine them together. So just x minus 8. Or you may call that -8 plus x. Both mean the same thing, okay? Both of those mean the same thing. I'm going to stick with this one. Okay. Now y is not by itself yet. It has this 2 being multiplied, so I need to divide every piece by 2. Now what I will get here is y equals, there's no number in front of this x. So what is that understood to be? It's actually understood, if there's no number there ever, we understand it to be a 1. So then I have 1 over 2. That does not reduce, so we'll just leave it as 1 over 2 and stick the x beside it. Now let's see, a -8 over 2 is a -4. So now I have y by itself, and now you can see that I have a slope, m equals 1/2, and I have a starting point. Now always be careful, so everybody see that negative belongs to it, so my starting point, my y-intercept is going to be at -4. Okay, and once again, just for our own visualization of this, let's label our rise and our run. So we're going to start at -4. So 1, 2, 3, 4, and put our starting point. And then from there we will do our change, how it's changing. It's going up 1. It's positive, so we're going up this time, right? Up 1 over 2. And we're always going to run to the right. So up 1 over 2, 1, 2. Put a dot. We need a third dot, so we're going to do this again. Up from the one we just drew, up 1 over 2. So we have 3 dots. They do appear to be in a straight line. I'm feeling good about what I've done. Awesome. Maybe one more graph, one more of something you can see. Let me copy this and put in another page here. One more. I'm going to go ahead and be nice to you and go ahead and give it to you y equals. Just know that you'll have to be able to solve for y, and we'll go with something like 3x minus 5. So you're looking here, and I see my slope is 3, and I see my y-intercept is -5. Be careful. Remember that negative belongs to it. So you know the starting point is at 1, 2, 3, 4, 5. -5 on the y-axis. But you look here, and there's no run. It's a whole number, right? Rise over run. But there's nothing down here. But I want you to think back to earlier in the semester when we took whole numbers, and I said, oh yeah, I can always turn this into something over 1, 3 over 1. So now I do have a rise and a run, okay? Always make sure if there's no denominator on your slope that you put a 1 there. So now I can go up 3 because it's positive, so I'll go up 1, 2, 3 over 1. 1, 2, 3 over 1. And do you see how fast it is to be able to graph those? A lot faster than having to make a table. So a lot of people really enjoy that method of graphing. Okay? So that's one big thing we've learned for the day so far, is how to graph using slope and intercept. You will be asked to do that on the test. So now, next what we want to get into is the meanings of slope and intercept in the context of word problems. So we're not actually going to do a word problem. What we're going to do is have a word problem that doesn't ask us any questions, but you will be asked to, hey, what is the slope of this? What's the y-intercept of this? And can you interpret them? Now, interpreting them comes from some of the discussions we've had over today and yesterday's class. So let's read the word problem first. So it says a small town university is expected to have a lot of growth in student population over the next few years. So that sets us up. But none of that really contains any math yet. So let's keep reading. So the number of students, y, in thousands, attending the university. So we're talking about the number of students, that's interesting, can be estimated by this linear equation right here, where x is the number of years after 2010. Okay, so that seems nice. We have some information there. Notice there's no question because this is not truly a word problem. It's just a setup. So now what we're going to ask you to do is we're going to ask you, hey, can you find the slope and can you find the y-intercept? Right off the bat. And all we need to do, let's get a highlighter here, is take our equation, and we know how to find slope and y-intercept. I just need to get y equals, right? I just need to solve for y. So that's not too hard. We know how to do that. So let's see. So this is a positive 21x, so I will subtract 21x from both sides. So that is a negative 25y equals. Now notice the negative 21x and the negative 50 are not like, because this one has an x and this one doesn't. So I cannot add or subtract those. I just write them out like that, negative 21x minus 50. Now I need to divide all three terms by negative 25. Okay, and watching very carefully, the negative 25s are gone, so I have y equals negative divided by negative is a positive, and 21 over 25 does not reduce. X, let's see, negative over a negative does make a positive, and 50 over 25 is 2. So there, I have found the slope and the y-intercept. So what is the slope of this linear equation? 21 over 25. What is the y-intercept? We found it to be 2. Or if you're thinking of the coordinate, that would be 0, 2. I'll take either answer. My math lab may be picky when they ask for an intercept, which way you give it to them. This is just the coordinate of that spot on the graph. Okay, so now we get, that's easy, that's simple. Now we get to the questions that tend to cause people to scratch their heads a little bit more. Can you interpret the slope? What does the slope mean in this context? You can't read it because of the watermark. Interpret the slope, okay? So what we're wanting you to do is write a complete sentence to interpret what the slope means. Okay, now let's think for a second. Remember last class we discussed what slope was. And slope, remember, is a rate of change. Rate of change. Okay, so we know what change means. A rate, remember, is just when we're comparing two things together. So we're comparing how two things change together. Well, what two things do we have? We have x and y. In the context of our problem, y, if you read it right here, it says that's the number of students in thousands. X, that's the number of years after 2010. So we must be wanting to see how things change as we go along, how y changes for each x. And so I actually have a little outline here to help you write the sentences. Okay, so something will increase or decrease by some amount for each x. So the something's, what's the y values? So something, well, what is the y value? That's the number of students in thousands. So we can shorten that. There's a phrase that means number of students. That's just population, right? Or you can write, the number of students. It does not really matter. The number of students. Okay. Well, now let's look at the slope. Is this a positive slope or a negative slope? Okay, that's a positive slope, so that means that the number of students will be increasing, so we'll increase by, now how much will it increase by? 21/25. Technically it's thousands. So if you want to add a note there, I include the unit from y units, with how much it will increase or decrease, if it makes sense to include it. If your sentence sounds stupid, then you can take it out. So the number of students will increase by some number of thousands for each, and it's going to be compared to each x value, okay, for each x value. What are the x values? X is the number of years after 2010. So that's all I need to put for each year after 2010. So let's read our sentence to see if it makes sense. So the number of students will increase by 21/25 thousandths for each year after 2010. Okay, well that makes sense. And that is telling me how the y value will change, how it will change compared to the x value. Okay, so that interprets the slope. So that's not too horrible at all, especially if you practice kind of filling out the sentence on the test. We'll need to make sure you write the sentence. We'll try to figure out how to do that on the test, but there you go. Okay, so now the next thing we're going to want to do is we found slope, we found y-intercept, we interpreted the slope. Now we want to interpret the y-intercept. What does the y-intercept mean? Well, this is very simple because the y-intercept, if you just think back to graphing, that meant our starting point, where we're starting this data at. And so what we're going to do is I have another little form sentence. Let me do this. So what does the y-intercept mean? It's so when are we starting? Okay, when do the x's start counting? Go up and read. It's actually really simple. X is the number of years after 2010. So the x's are starting counting in 2010. So we can just say in 2010, that's when we're starting counting the x's. Okay, and then the y value is what? So let's see. What is it's 2, but what are the units? The y value is thousands. So in 2010, there are 2,000 students attending the university. So what is the y value? That's the students, the number of students attending the university. So the y value is 2,000 students attended the university. So it's our starting point. What's the x value of the starting point? That's in the year 2010. What's the y value of the starting point? 2 or 2,000, since it was in thousands. 2,000 students attended the university. So it's just that simple. That's what the y-intercept means is, okay, where are we starting at? Give me the x value, give me the y value, and make it into a sentence. Okay? Awesome. Alright, so one last topic. So we can find slope and y-intercept. We can graph using slope and y-intercept. We can interpret slope and intercept. The last thing we want to do is that we're going to start some baby steps towards writing equations. Okay, and this is going to be super simple. I'm going to give you a slope, and I'm going to give you a y-intercept. Okay, and actually, instead of writing it as b, I will write the y-intercept as a point, as an ordered pair, just to get you used to seeing it. So let's do this. Slope of negative 2/3, y-intercept of 0, -5. Could you write the equation? Well, yeah, this is really simple, because remember, all I have to do to write the equation is put in the slope and put in the y-intercept, which is just -5 here. That's the b. When I write it as a point, it's 0, whatever the b is. So could I write this as an equation? So y equals, well, what's the slope? -2/3. Don't forget the x, plus, what's the b? The b is -5. So it's probably going to be better to write this as -5, just to be more formal. Whenever you have a negative b, it's fancier to write it that way. So this is just to introduce the idea of writing equations to you. That's really actually kind of simple. So I could put any number here and any number here. They could be as nasty as you can imagine. All you're doing is plopping them in right here and right here. So let me do another one. Slope is 7, and the y-intercept is, I don't know, we can make it nasty like a fraction. 0, 4/9. Not pretty numbers, but all I'm going to do is y equals something x. What's the something? Slope is 7. And then plus b. Well, what's the b? 4/9. It's positive this time, so I'll go with plus 4/9. So you can write equations if you're given the y-intercept and the slope really easily. We're going to be interested in writing equations, and we're going to have to expand our abilities over the next few lessons when it comes to writing equations, but this is the starting point. All right? Be sure to do my Math Lab homework. Be sure to do your worksheet, and that's all I got for you today. Have a good day, guys.